All right, so let's start by talking about differential equations and what they are. Now, you are already familiar with just equations. And from your various math experiences, math classes, you're used to simple things like this, and this is super simple. We can get way more complicated than this, obviously. But there's an equation. And the goal of an equation very often is to solve it. In other words, to find a variable or a number that you can substitute into the variable to make the equation true. And we've got methods for solving this one, right? We can go through the algebra and subtract 3 and divide by 2, so we get x equals 9 halves, right? And that is a solution to the equation, because if you plug it back in to the equation, you get the left-hand side equaling the right-hand side. And so you're familiar already with the idea of solving equations. So differential equations are equations that we want to solve. In this example that we just showed you, we were solving for the variable x. What value do we plug in for the variable x to make this equation true? All right. But a differential equation, first of all, a differential equation, we're going to refer to them as diffeq's, right? A differential equation is an equation that involves the derivatives of a function as well as maybe other variables. So we could have something as simple as this: dy dx equals, here, f of x, some function of x. Okay, there's a differential equation. It's an equation, right? It has an equal sign. And it involves a function dy dx. And of course, we got to get used to the notation. When we see f of x, that's just going to be some function of x. So for example, it could just be x squared plus 2x minus 1, right? And there it is, right? Now, we can get more complicated. Here's one: dy dx equals x y plus 3. Right? Now you notice this one. This one involves the derivative, but the derivative of y, let me write it this way because sometimes this is helpful, right? dy dx is the same as y prime equals x y plus 3. So this function, the unknown, the thing we are trying to solve for, is y, right? So what we're after up here when we're solving an equation, we're trying to find the solution, and we know the solution is a number. But in a differential equation, the solution is an equation, and it is y. So we want to find some function y that satisfies this. Now, so y in this case represents an entire function. X is just the variable. Y will be a function in x. All right, a function of x. So when we're trying to when we are asked to solve a differential equation like this, the answer will be some function of x, right? That's what we're asking. That's what we're trying to find. So here's another example. We'll talk about solving these as we go along, but here's another example. Remember your notation here. So it becomes really important, maybe for the first time that you've been aware of, this notation, this dy dx notation, becomes really important to remind us that y is a function, x is a variable. Okay, y is a function of x. All right, and so when we look at this differential equation, it involves y prime. Again, sometimes it's easier to write it like this. It involves y double prime plus 3y prime plus 7y equals 0. So if I needed to solve this, I would need to find a function y so that when I took its second derivative and added 3 times its first derivative plus 7 times the function itself, I get 0. And that's what it means to solve a differential equation. So when we're looking for differential equations and we're solving differential equations, the answers that will show up will be functions. Functions that will most often use y, that's our simplest designation, but they will be functions in the variable x. All right. So let's look at another example. So here's a differential equation, dy dx equals 2xy. And so I'm going to ask a slightly different question here, and that is this. This is, again, you'll recognize this kind of question. Is y of x equal c e to the x squared a solution to this differential equation? Right? Now, we've seen those kinds of questions back when we're in algebra. When you're solving equations, you get those kinds of questions all the time. Here's an equation. Is 5 a solution? And of course, we know in order to determine if 5 is a solution, you're going to try to plug it in and see if it makes the left-hand side equal the right-hand side. So that's the same thing happening here. I'm giving you a differential equation. I'm giving you that something that may or may not be a solution. I'm asking you to determine if it is a solution. And so to determine if it's a solution, you're going to plug it in, right? It's as simple as that. So what we need is here, we need its derivative, right? We need dy dx. We need y prime. So dy dx, we need to find that. So again, you see why we need to be able to differentiate. So the derivative of this is going to be, using the chain rule, c e to the x squared times 2x. Or if we clean it up, 2 times c x e to the x squared. Just write it a little more friendly. And so that will be the derivative, and that will go right here. And the question is, if I put that right there, 2cx e to the x squared, does that equal, we'll put a question mark there because that's what we're trying to determine, does that equal c, the right-hand side, which is 2 times x times y, which is c e to the x squared? And I think we can just take a second and confirm that those two sides are actually equal. So the answer is yes, this is a solution, because when we plug that function into the differential equation, we get a true statement. All right, let's try another example here. So again, keeping with the idea of something we're very familiar with, that is verifying something is a solution. So verify that y of x equals 1/4 x to the 5th plus c x to the minus 3 is a solution to the differential equation x dy dx plus 3y equals 2x to the 5th equals 2x to the 5th. Okay, now just a point of explanation. You're going to have to get used to this. When we use c in here, it just represents a constant. So this is just a coefficient on this term. It could represent any constant. Okay, we'll talk more about that here in a second. But let's get down to the business of verifying this. And so basically what that means is this a solution if I were to substitute this into the differential equation for the y's and the dy's? Will the equation be true? So of course what I need the derivative, right, in order to do that. So I need to know what dy dx is, and just taking our derivative the normal way, derivative is 5/4 x to the 4th minus 3c x to the minus 4th, right? And that's our first derivative. And so let's plug that in. So we have x, let's do it here, x times the derivative, 5/4 x to the 4th minus 3c x to the minus 4th plus 3 times y, and of course y is 1/4 x to the 5th plus c x to the minus 3rd. And the question is, does that equal 2x to the 5th? Now notice we only plug in the the function in for the y's. X's just are built into this equation, and they stay there. So if I do a little algebra here, we're going to have 5/4 x to the 5th minus 3c x to the minus 3rd plus 3/4 x to the 5th plus 3c x to the minus 3rd. And let's just take a little look here. It looks like this term and this term are going to disappear, and we're left with 5/4 x to the 5th plus 3/4 x to the 5th, which of course is 8/4 x to the 5th, or yes, 2x to the 5th. So we've verified it. We've shown that if I plug this function right here into this differential equation for y and the derivative of y, it becomes true. All right, we get a true mathematical expression. And so that's what we're all about. That's what a differential equation is. The solution to a differential equation is hopefully, ideally, an equation, a function. We just have to get used to the y's and the x's. Y being the function, x just being our general variables. And now, the topic of solving differential equations, of having somebody give you a differential equation and then you finding the solution, that's way more complicated. And that's what we're going to spend our time doing a little bit in this course. But we wanted you to, I wanted to introduce you to the idea of a differential equation. We'll talk about some more terminology as we go along here, but that gets you started on what a differential equation is and what it means to be a solution to the differential equation.